Hello students. Today we'll see the example 3.22. The total sale. This is the formula we already learned. The total sale is 0 to R f of t dt. The same formula we're using here. The total inventory cost is 0 to time. It is always a time here, and in I of x into dx, where t is the upper limit of the time given. And here you have to multiply because the unit holding cost will be given in the question. The unit holding cost of holding per unit will be given. So you have to multiply this by C1. To find the total holding cost, you have to multiply this by C1. So the total inventory cost is this. So a company receives a shipment of 200 cars every 30 days. It receives a shipment of 200 cars every 30 days. Every 30 days it receives 200 cars. From experience, it is known that the inventory on hand is related to the number of days. Inventory, that is the storage, is depending on the number of days. Since the last shipment is this I of x, that is, it is the inventory is depending, it is related to the number of days. So here x is the number of days. So the inventory is depending on the number of days. They are related to the number of days. So as x increases, the inventory cost will increase. As x changes, the number of days changes, the inventory cost will change. So the inventory cost is depending on x. Find the daily holding cost for maintaining inventory for 30 days. Okay, the inventory means the product, the goods that you are storing. For 30 days, if the daily holding cost is 3.5. So the daily holding cost of a car is 3.5 rupees. So inventory, the function given here is 200 minus 0.2x. C1, the holding cost. Okay, daily holding cost is given as 3.5. Number of days is 30. So the total inventory cost is C1, 0 to R. R is the upper limit of the number of days. Here it is 30. Okay, 30. So 0 to 30. The inventory function is given as 200 minus 0.2x into dx. So that is 3.5. 200, integration of 200 is 200x. Integration of a constant is kx minus 0.2, x integration is x square by 2. The limit is from 0 to 30. So put the limit, it is 3.5, 200 into 30 minus, you can cancel this, 0.1. So minus 0.1 into 30 square, minus the lower limit is 0, so just leave it. 6000 minus 900, that is 90. 900 and into 0.1 will give you 90. Now subtract 6000 minus 90. So that is 3.5 into 5910 into 3.5. Is 20,685. The amount of annuity after n payments. So the formula is P integration of the amount of annuity formula is, that is the future value. The future value, the formula is 0 to n P e power RT. If you deposit some amount and the amount after 10 years or after 20 years, this is the formula. But if they give the amount here, the amount is given, they ask you the present value. If they ask you the present value, that is you're going back. The present value if they ask, the formula will be, the present value formula is 0 to n P e power minus RT. The present value formula is this. The future value formula, the amount of annuity after n payments, this is the formula 0 to n or r you can write, or k can be 0 to k P e power RT dt, where k is the upper limit of the time given. In example 3, Mr. Arul invests 10,000 in a bank which pays an interest of 10% per annum, compounded continuously. So continuously it is compounded for 5 years. That is, the growth is exponential. There is an exponential growth for 5 years. How much amount will be there after 5 years? So the upper limit of time is 5. So 0 to 5, P is the amount you are depositing, 10,000. E power RT. R is e power RT. The formula is P into e power RT. P is 10,000. E power R is the 10%. So 10% is 10 by 100. That is nothing but 0.1 into T dt. So if they ask you the annuity, that is amount after 5 years, this is a formula. If they ask you what is the present value, the formula will be e power minus RT. So this is 10,000 e power 0.1 t. The e power at, integration of e power at is e power at divided by a. So e power 0.1 t divided by 0.1, and the limit is from 0 to 5. So apply the upper limit first. So this is 10,000 by 0.1, add one more 0, it will become 1 lakh. E power 0.1 into 5 is 0.5 minus the lower limit is e power 0. E power 0 value is 1. Now e power 0.5, the value is given 1.6487. 1.6487 minus 1 is 0.6487 multiplied by 1 lakh, 64,870 rupees. So amount after 5 years. If you deposit 10,000 in a bank, rate of interest compounded continuously, the amount that you receive after 5 years will be 64,870. If the rate of interest is 10% and it is compounded continuously for 5 years. Example 3.24. In the year 2000, the world gold production was 2,547. So in the year 2000, this is the production, and it was growing exponentially, exponential growth. The rate is 0.6%. If the growth continues at this rate, how many tons of gold will be produced from 2000 to 2013? So there is an exponential growth. So there is the previous sum, they said compounded continuously. Compounded continuously is also is exponential growth. So here instead of the word compounded continuously, they have used the word exponentially. The growth is exponential growth. So again, the same formula that you are going to use. The amount formula is P e power RT into dt. Okay. So this is the formula. The limit is from 0 to the number of years. So here 13 years, from 2000 to 2013, 13 years. So 0 to 13, P is initial amount. Initial amount is 2,547 metric tons. E power 0.006 into T. That is because the rate is 0.6%. Your R is the rate. So 0.6% means 0.6 by 100. That is nothing but 0.006 into T. If you integrate this, it will become e power at. Integration is e power at divided by a. So e power this divided by this constant 0.006. Apply the limit 0 to 13. So e power 0.006 into 13 is e power 0.078 minus 1. Now e power 0.078 value is given as 1.0811. So substitute that 4,24,000. E power 0.078 is 1.0811 minus 1. Okay, so that is 4,24,500. Now subtract 0.0811. Now multiply this, you will get 34,426.95 metric tons. So after 13 years, it will be 34,426.95 metric tons. Next is elasticity of demand and the demand function. The demand function from elasticity of demand. So elasticity of the demand is, this is the formula, elasticity of demand. Elasticity of demand, there is a negative sign. The demand function is a decreasing function. So slope will be decreasing. So the formula will have a negative sign. Demand function minus P by X dx by dP. If they just ask you find the elasticity, this is the formula. Elasticity formula is X by Y dy by dx. If nothing is mentioned, that is demand or supply, if nothing is mentioned, just elasticity of the function X by Y dy by dx. Elasticity of supply, there is no minus sign. P by X dx by dP. So in this question, example 3.25, elasticity is given. The elasticity function is given as this. So find the function. This is the elasticity function given. Find the original function. That's the question. So elasticity formula is X by Y. Elasticity, the formula is X by Y dy by dx. So that is given. X by Y dy by dx is given. So we have to find the function. So separate the variables. There is something called as variable separable. Variable separable means you are going to find the original function. There is a differentiation here. To find the original function, you have to take the reverse process. The reverse process of differentiation is integration. So only when you integrate, you get the original function y in terms of x. So we want the original function. That's what question is. The elasticity function is given. Find the original function. To find the original function, you have to integrate. To integrate this, you have to separate the variables. So how do you separate the variables? The dy is here. Keep dy terms left side and all the x and dx to the right side. So dy by y, you can cancel this x and x. So you get dy by y is equal to dx by x minus 2. Okay, when you separate the variables, dy by y is dx by x minus 2. Now integrate. After separating the variables, you can integrate. So integration of 1 by y is log y. Integration of 1 by x minus 2 is log x minus 2. And there is a constant. Because you have log everywhere, the constant you can write it as log k. Usually we write as c or k. But because you have log everywhere, if you put log k, it will be easy for your calculation. So now use the product rule here. Log a plus log b. The product rule in logs. So log a plus log b is log a into b. That is k into x minus 2. So you get log y is log x minus 2 into k. Now you remove log. This log and this log. You remove log from both the sides. So you get y is equal to k into x minus 2. Now they have given some values here. To find the function, x is 6 and y is 16. So put the values here. Put x is 6 and y is 16. So in the place of y you put 16. In the place of x you put 6. 6 minus 2, that is 4k. 4k is 16. So k is 4. So put that k in this function. This is the function we got. So y is equal to k into x minus 2, k is 4. So 4 into x minus 2. See the example 3.26. The elasticity of demand is given. The elasticity of demand is given. Okay, find the demand function. The previous sum, elasticity was given. Here the elasticity of demand. So elasticity of demand is given. So what is the formula to find the elasticity of demand? Minus p by x. Whenever the demand function is there, then you have to put a minus sign. Minus p by x dx by dp is equal to this. Take out p, common outside. So you'll get 2p plus 1. So dx by x. Now separate the variables. You're going to find the original function. Find the demand function. What is given is the elasticity of demand. To find the original function, you have to integrate this. To integrate this, you have to separate the variables. So what you should do? Dx and x you keep it here. Dp, p take it to the side. You can cancel this p. See this p and this p you can cancel. And this minus you bring it down. So this is dx by x and this dp goes up. So 2p plus 1 by this minus you bring it down. So the sign will change. P square plus p minus 100. And the dp also keep it here. This minus is changing the sign here. So now integrate. Dx by x is x. And look at this, p square. Differentiation is 2p. P differentiation is 1. So there is a formula. If the differentiation of the denominator is there in the numerator, when the differentiation of the denominator is there in the numerator, then this is the integral is log of the denominator. Remember that. So whenever you have the differentiation of the denominator, so you can see p square differentiation is 2p. P differentiation of p, like differentiation of x is 1. The differentiation of p is 1. 100, differentiation of 100 is 0. Differentiation of a constant is 0. So you have the differentiation in the numerator. So the integral of this will be log of the denominator. Since you have log everywhere, you can put the constant also as log k. So now use the product rule. Log x is equal to log product rule. Log a plus log b is log a into b. This is a minus sign here. Log a into b. Now remove this log from both the sides. So x is equal to this. K into p square plus p minus 100. They given here. To find the function, they have given the price is 5 and the demand is 70. The price is p. The price p is 5. So put p is 5 and x is, the demand is 70. Function is x is equal to k into p square plus p minus 100. You put x is 70 and p is 5. So we get 25 plus 5 minus 100. So that is 25 plus 5, 30 minus 100 is minus 70. So 70 is equal to minus 70k. So k is minus 1. So that k you put it here. So what happens to the function now? The function is actually x is equal to k into p square plus p minus 100. You got the k as minus 1. So x is equal to, change the sign. So it will become 100 minus p square minus p. Because your k is minus 1. So that's what is given here. X is 100 minus p square. This is the demand function. Revenue is there. They didn't ask you revenue. The revenue function is R is equal to P into X. So multiply by P. This you will get the revenue function.